Welcome to Datadog Illuminated. Here's how most teams evaluate the success of AI tools. First, a human writes a question. Second, a human figures out the correct answer. And then, if the AI gets the same answer as the human, then the eval passes. This is the standard approach, and as you can imagine, it's painfully slow. There's a lot of human toil involved. So Scott Yak and Datadog's applied AI team face even more friction when evaluating the Datadog MCP server. For one thing, they're evaluating it against live data that can go stale fast. So the answers to the human-made question-answer pairs can change. And if that isn't enough, Datadog's applied AI team needs to evaluate a bajillion scenarios. Wait, that's the official number? A bajillion? All right, a bajillion scenarios. Because the Datadog MCP server has to handle anything a user might want to do, search log, query metrics, filter by status codes,
filter by IP addresses, filter by time ranges, filter by Boolean operations.
And again, they're evaluating those bajillion scenarios against live data that changes. And they found a way to keep up, albeit a controversial one. So how does Scott Yak and his team do it? How do they generate that many evals without drowning in toil? What do they do when their data expires faster than they can update it? And why do developers on Scott's team actually want to write evals when usually nobody does? Thank goodness Scott is here to explain it all. Let's do this. All right, I'm here with my colleague and friend Scott. Scott, will you introduce yourself, please?
I'm Scott Yak. I'm a senior software engineer at Datadog MCP server under Applied AI.
We're going to talk about the Datadog MCP server today. Is that true?
Yes, we're going to talk about evals. It's a thing that people love and hate.
Let's just dig in about what is an eval and what makes it different from a test.
So normally when you think about tests, say you want to check that, say, a function produces the correct output given a certain input. Then you will write a test to make sure that does produce that correct answer. For evals, these tend to be more LLM specific things. Say you give it a prompt, you give it a question, does it actually answer the question in the way that you want? So that is an eval. Right. Usually evals are associated with systems that have LLMs inside because LLMs, they can answer a question in different ways. They might phrase it differently. And so you want to evaluate the behavior. You can take several routes to get there.
That's very helpful context right up top. I want to go through my experience as a Datadog MCP server user and just talk about where the MCP server sits in the stack. So I might ask a question like, how many errors are in checkout? So I ask that question, and I ask that question to my coding agent. And for me, that's going to be Cloud Code, but it could be Cursor, any of the other ones. It could be a custom agent. It doesn't have to be Cloud Code. And then that agent is wrapping an LLM. So then that agent is what's calling the Datadog MCP server. And then the Datadog MCP server is communicating with my Datadog backend. And then that Datadog backend is what's going to return a response. We'll say 42 errors. And so that response gets returned to Datadog MCP, back to the agent that's wrapping an LLM, and then back to answer my question. Okay, this has all been an elaborate setup. All of this is to say, why are we doing evals, not tests? Because the Datadog MCP server is asking testable question to the Datadog backend and getting a testable answer. Where does the eval part come in?
The MCP server is often a thin wrapper around the API. So the API is where a lot of the hard work is happening. The backend is doing a lot of work. The MCP server adds some description to that. It just takes a query and then it gets back a response. And it is somewhat deterministic, but the whole thing is not really deterministic. Why do we care about that the whole thing works together? Is that the way that users use it is by asking a natural language question. So they are not actually passing in the exact query syntax that you will call the API with. If you call the API, you will have to get the syntax exactly right for it to give you the right answer. But the way that users expect to interact with MCP servers is that they're going to ask a question after the agent is connected to the MCP server. And they're just going to expect that the agent can figure out how to call this tool. So our tools expose a pretty complex query syntax. And we have to make sure that when the way it responds, the way that it does validation, and the way it's documented, parameters, all that makes sense to the LLM when that is connected to it. So we want to make sure that the users, when they ask this question, the LLM that is on their side that we don't control knows how to use our query syntax.
So you're really testing more about the Datadog MCP between the agent layer, making sure the agent is asking good questions and getting good responses, and the MCP server is guiding the agent to do that as much as it can. Then you are the Datadog MCP between the Datadog backend layer. So now my question is, what are the evals that you're building? How are we doing it? Let's do how.
At a high level, there's an agent loop that you ask a question and it gives you a response. And what it consists of is an agent harness like Cloud Code that you connect to our Datadog MCP server. And then you ask it a question, how many errors were there from this service? Then this agent harness is able to use this as to make a tool call and then get back the expected response. From that, you will get a response and you want to have some way to verify that this response is correct. And the way that we do that right now is by having the correct answer to this question. Say, if you were to ask how many errors were there from this service from between this time and that time, that will give you one unique correct answer.
So an eval has 3 ingredients: an agent harness, the Datadog MCP server, and a Q&A pair. Basically, you want to ask the queue of the Q&A pair through the stack, and you want the actual response to equal the expected response as defined in the A of the Q&A pair.
It doesn't have to be exactly the same. So the scorers don't necessarily have to do an exact match between the actual response and the expected response. So yeah, but in our case, if you want to make it very easy to verify, you would want to have some mechanical way to compare the actual response to the expected response, but it don't have to be exactly the same. You just need to have a way to make sure that you can score the response using some information you know about this question.
Is that because, again, we're dealing with LLMs and we can't have like an exact word match, or is it more to do with testing different levels of success?
So it depends on how complicated the question you are asking to this agent. So if you're asking a question like how many, then you can do an exact match, because you can do an exact match. Okay, how like 43 equals 43. Okay, that's an easy way to verify the response. But if you are going to evaluate things like help me investigate the root cause of this thing, and you can generate a whole essay and a report of I think it's this, it could be that, it could be that. And different LLMs are going to write different essays. And even if you know the correct answer, it's not going to give you the exact answer word for word. So you can't do the exact match for that. So that's why in general, evals don't always do exact match. You could use LLM as a judge. You can do some kind of fuzzy match. You can break down the answer into pieces and then verify those pieces separately. But overall, in general, evaluations, they don't have to be exact match. But in that example of how many errors at checkout between this time and that time, you can use an exact match.
That makes total sense. And I have another quick question at this level, which is, we talked about how to do one eval, which is cool. But what's like the scale?
So what kinds of tools we're exposing through the Datadog MCP server? We're exposing search logs, search queries, find traces. There's also more. Those are just 3 of them. There's, I think, 15 different tools. And each of them, and often, the way that you get data from Datadog requires some kind of query syntax, which is quite complex. There are wildcards, you have booleans, you need to get there are reserved attributes, there are escape characters, things like that. So just for comprehensive evals for search logs, you need to cover all these different cases. And you also want to make sure that in a single eval scenario, you can combine both wildcards and booleans, and maybe also reserve tags. It does mean that you probably need a few hundred evals for each tool. So that's just for search logs. The metrics also, on the order of 100. It is a lot of work to make all these things work. When the backend data changes, your expected answer also changes. That makes it even more tricky to get it right.
Oh, so not only do you need a ton of questions, but those questions go stale pretty quickly.
The answers go stale.
The answers, yes. Okay. How do you maintain that? That piece of it seems very labor intensive.
One controversial idea that we had, thanks to our PM for suggesting it, is to automate the way we generate our evals. That was a bit controversial because it wasn't clear that it was possible. The reason for that is that, let's say you start with the question, like how many errors in checkout at this time. You wanted to come up with the right answer, but it would not be so straightforward for you to figure out because you needed an agent to do it in the first place, right? That's why we're providing it as a service. So it's not so straightforward to go from the question to the answer. The trick here is that you can start from some C query. There's a query that you know conforms to the syntax and will give you some reasonable thing. And that query corresponds to a natural language question. And you can take this exact query and make an API call because it's already a correct query. You know exactly how to write the code to get the exact answer from your backend.
You start with a seed query. So like maybe, I mean, this isn't the proper syntax, but we're saying service is checkout, status is 500. And then from that seed query, we call the Datadog API, which is a very known thing. And then we get our response, which is the 42 errors. We have the query and the answer, but we don't have the question.
So from here, there are a few different ways of doing it. One way you can do it is by noting that the query syntax is actually, there you can parse it into syntax, into some abstract syntax tree. There's a tree that corresponds to the verbs and the nouns and the adjectives. And that also maps to, say, a correct English sentence, right? English sentence also, you can treat it like a parse tree, like subject, verbs, object. So there is some way to map from this query into a natural language sentence. So that's one way to do it. And in fact, you can use synonyms. You can have multiple templates so that you go from one single seed query into multiple natural language questions in a deterministic way. That's one way of doing it. Another way of doing it is to use the LLM to go from the query into the natural language question. That's another way of doing it. We are still exploring at this point. There are pros and cons to each of this approach. But the general point is that you can start from a seed query and automatically generate a bunch of natural language questions that have that answer.
Excellent. Is that called fuzzing?
But in general, fuzzing means that you are trying to have several variations of errors. So if you were to say you take the correct answer and then you mess around with it in different ways, maybe you find that it fails in certain ways. And what you can do here is that you can actually either prompt the LLM or you can set the mapping so it gives more challenging questions. So for example, there's a way you could ask in a very direct way, like how many status 500 do I see in service checkout? So that would be relatively easy because you know that this person is already thinking in Datadog terms. Right? And that is relatively easy for the LLM to map into the query syntax. If you're asking show checkout service 500 errors, it doesn't map so directly into the query syntax, right? The LLM needs to do a bit more work to map that into the exact query syntax. So that will be a bit more challenge. So that's why, we can call it fuzzing. You are trying to generate a whole bunch of different ways that it could fail.
So, okay, I'll put that in quotes since we're kind of using it. We're using fuzzy in a fuzzy way. Awesome. So instead of having to manually maintain this large quantity of Q&A pairs, you're able to automate it just by starting with a seed query. And then with that seed query, you have an answer that you definitely know. And then you can use various techniques that you described to create questions with that answer. And then it sounds like you can maintain those questions.
The nice thing about this especially the nice thing about this approach is that, yes, one seed gives you many question answer pairs. And these seed queries, they don't expire the way that the answers might if the data goes stale. And the reason for that is that you can rerun those things. Say, normally, if you want to make sure that you are going to call, so how many errors in checkout in the last 3 days, right? So perhaps your data disappears after a certain number of days because of retention policy. But then after that time, you can rerun your script to turn that C query into API calls and generate the same questions again. And then you're going to call the real backend and then get the real answers. And then now you have a fresh set of answers that now work again.
We talked about how it works, like why we even need to write evals, what an eval is exactly, and then how to do what you can to automate all of your question and answers so that you can create and maintain a large volume of evals, which is necessary to really understand the health of your MCP server. So let's talk about what makes an eval great.
It shouldn't be too hard to make evals.
Okay.
I think people hate making evals, but if you don't like making them, then you don't have a lot of them to verify that your system is working the way that you want it to be. The other thing about evals is that they shouldn't fail when it's not actually failing unless something's actually going wrong. And then you should have enough of them
Lots of them.
so that they can cover the use cases that people actually expect to use it with.
Nice way to say that. Good coverage.
Good coverage is especially helpful for MCP servers, because what will people expect the MCP server to be able to do, right? They would expect to have it to do what the documentation says that you can do with Datadog's API, for example, or Datadog's core, logs explorer. That comes with certain expectations, and then you want to make sure that people can do with MCP servers what you can do with Datadog.
Yeah.
And
Absolutely. And that's a lot. So what is a benefit of great evaluations?
So one thing that is one thing I'm proud of about our evaluations is that it is relatively fast. So fast to generate evals is the speed of it. Right? It's fast to generate evals, and it's fast to run those evals. The way that we generate evals for our search logs tool is that we go to the log search syntax documentation. We take the markdown version, we pass the Claude code, and we say, okay, categorize this syntax by different source capabilities, and then help it write the C queries. So you ask Claude Code to help us write the C queries, and then we test to make sure that these C queries actually work. We probably have to twiddle it a bit to make sure that the service names actually exist. But overall, the process to generate a few hundred eval scenarios takes, I think, 1 day, which is actually very nice. Like, this is a project that this sort of thing usually takes weeks of time, or sometimes even months. Evals are generally a very painstaking process. And being able to automate them is great. Then the other thing is that being able to run evals is also fast. The way we set up our evals are such that remember that this agent harness and MCP server Q&A pair, the queries ask a very specific question, right? It asks like how many errors to check out. So if our MCP server is documented correctly and such that the LLM knows how to call the right tool, it takes roughly maybe 3 to 5 turns to get the right answer. And that means it's fast, right? Because say a normal agent, perhaps something that is trying to do something more complicated, like an investigation, it can take 50 to 100 turns. So it takes a long time to run those evals. And you probably want to have a more powerful LLM. But for these sort of cases, we can use a cheaper or faster LLM like Claude Haiku to run this. And the reason why we can get away with that is that like cheaper and faster LLMs actually make it more challenging, because we are trying to make sure that our MCP servers can actually are well documented and well implemented, so that even if your LLM is maybe not the best, you can still use it, right?
Yeah.
And so we have very simple scenarios that take very few turns, and that we can use fast and cheap LLMs. Makes it such that each eval scenario takes a short time to run.
That makes a lot of sense. Because again, you don't have any control over this layer in the stack, but you want to ensure that you interact with it well. So it makes sense to me that you would test with a cheaper model, because if a cheaper model can get it right, then you can assume that the more expensive models can.
Exactly. Yeah.
And cool.
Okay.
So you said they're fast to generate, they're also fast to run. What does fast to run look like exactly?
Right. Yeah, it takes about 2 minutes to run 200 eval scenarios.
Wow.
And that's on a local computer. Yeah. So if you are changing your MCP server and you are running it locally, and you want to quickly see, okay, did my change make things better or worse? Like the fact that you can run in 2 minutes, it means that you can also quickly see the impact. And we have set up our eval harness, or our agent harness, so that it will report those things to a dashboard. And so we can quickly run this thing, you generate a URL, we click on this thing, and then we can see this visualization that tells us, is it better or is it worse?
So because they're fast to run, you can get them visualized quickly, and you can immediately see the impacts that your code changes make.
And besides that, so now that you have say 200 or hundreds of evals, you start having like a way to have more visibility in the progress of your MCP servers, right? When you are making MCP servers, you want to know if you're making it better. Like people are writing blog posts all the time about, this is how here is the trick to make an MCP server better, but you want to know like what actually makes it better.
So into the progress, the development progress.
When you have a lot of evals, that allows you to say, okay, last week my score was 0.6. This week my score is 0.7. Clearly, it is overall better. So that is the average score itself will tell you, when you have enough evals, that your MCP server is getting better. The other thing that you can do with it is that, let's say your score remains the same. It doesn't necessarily mean that nothing changed. It could be that something got better and something got worse. Right? Sometimes you will make a change to one part of your MCP server, and it's a big change, and you expect someone to change to be different, and it stays the same. This is where you can actually do a deeper dive life. But rather than eyeballing these 200 eval scenarios and seeing, okay, this is better, this is worse, you can tag each eval scenario with what is actually evaluating. Say, you can say, okay, this is an eval scenario that uses Boolean. This is an eval scenario where the query uses a wildcard, for example. They might even overlap because a single eval scenario might require the LLM to write a query that has both Booleans and wildcards. Then you can do, with all these tags, you can do a group by over those evals to say, okay, based on this grouping, I can see that the average score for this, or say Booleans went up by this much, but for wildcards it went down by this much. And then you can see, okay, maybe I need to tweak the prompts, or I need to tweak the description a bit to make sure that it knows how to do that, and so that the scores all go up.
So you can look at like all the evals and kind of get an idea of overall MCP server progress. Or you can tag individual evals, and then you can be like, oh, our Boolean queries are doing better, but our wildcard queries are doing worse. And you can get like more insight into what exactly is changing.
Yeah, because you might have 10 or you might have 5 or 10 eval scenarios that that involve this, that have the same tag. So you can check that. Yeah. When something fails, you kind of want to know where it went wrong. And sometimes, as I mentioned, that when it all goes well, it's like it gets it in 3 to 5 turns. But when it goes wrong, you want to know exactly where it went wrong. And so the way that we instrument our harness is that it will store every single turn that the agent harness made. So it starts off with the system prompt, and then you have the LLM maybe thinks a little bit, and then it figures out that it needs to make this tool call, and then it gets tool response, and then after it takes the tool response, and then if anything goes wrong in any of those steps, then it might go wrong. Or it may be that the first tool call, it did something wrong, and then it recovered quite gracefully because the response did something nice. And so for that, we have traces. So these are the traces of every single eval scenario that we can dive in and see, okay, where did it go wrong?
So you're saying 3 to 5 turns or longer depending. And when you say that, a turn is like an agent asking a question, getting a response, and figuring out something from that response and asking again, and like that each of those is a turn.
Depends on how you define it. At least the way that I have thought about it is that I think of it as like messages. I think about it in terms of messages. So yeah, yes, a turn would involve, typically a turn would involve, an MCP tool call. You want to minimize the number of tool calls it takes to answer a question. But yeah, the way I was thinking about it is that, you have that there are a bunch of things that happen, like the LLM will do something, and then it will call the tool, and then the tool will respond, and then the LLM will then take that response and do something else. So but you want to kind of step into each of these tiny steps to see where it went wrong. Yeah.
And so having a large amount of great evals helps you trace through that and understand exactly which tool call, which process, which query, what was the holdup. Cool.
Yeah.
Very cool.
And then, so what else? So the great thing about, having our own evals. So right now, these are evals that are produced by like the MCP server team. But those are not the only evals. Agent teams, say, for example, Datadog also has Biz AI SRE and Biz AI assistants that need to use tools, and they are free to use different ways to get tools. But for us, when we try to improve our MCP server before it actually affects them negatively. So we want to debug very obvious tool call failures that we can debug first. Like just make sure that we can actually answer obvious questions, like things like how many errors in checkout. Right? We shouldn't need the agent evals to hit those errors before they get that they are able to know that the tools have something wrong. But the better our MCP servers are, we can get more first-party agents like Datadog AI agents to adopt them. And what that means is that when they adopt our MCP servers, it means that as we improve our MCP server, their agents also get better.
So there's mutual benefit. So what I'm hearing is, first of all, when you say Datadog first-party agent, AI agents, you're explain that to me again.
Yeah. So first party is as opposed to third party. So when we build the MCP server, it is a remote MCP server, which means that people outside of Datadog can connect to it. Right?
Okay.
They pass this URL to Cloud Code, and they can use it to make their own agents. So we call those third party agents. Right?
Okay.
So first party agents are agents that are created by Datadog. So internally, we have agents like BizAI SRE and BizAI Assistant. So, and they do also use the tools. And they are also users of Datadog MCP server.
When you improve the MCP server, you're also improving these two products and any other like Datadog products that are using the Datadog MCP server and third-party things that are using the MCP server.
That's right.
So you have like downstream improvement. So better MCP server equals better agents.
And because they are adopting our MCP server, they now want to give us feedback. Right? So we have certain our own evals perhaps cover the simple cases, but the AI agents they want to do more complicated things. They want to multi-turn, like they want the programs like try combinations, some obscure combination of tool calls, right? So they will give us feedback, like perhaps there's this obscure thing that they want that we didn't think of, and so they give us feedback to improve this thing. And maybe it's not so obscure, you just didn't think about it. And that means that when one agent team gives us feedback, we improve the MCP server, and then another AI agent team that uses the MCP server also benefits indirectly. Like they don't even have to give us the bug report. They just know that their MCP tools got better.
And then this relates back to evals in that when you get that feedback, you can turn that feedback into evals for the MCP server.
That's right. Yeah. So it has happened before. Like say, there's this tool call that didn't quite work, and they were wondering why. And we could hand code an eval scenario to make sure that doesn't happen again. Yeah. Also having those evals make it easier for us to debug. And like sometimes when people give reports, they might say, okay, I think that you had this tool call that wasn't working. I'm guessing it's because you can't handle this case. And then we look at our evals and we can see, oh, actually, we do have evals to show that it works pretty reliably in this case.
Maybe an agent team thinks that your wildcard doesn't work. Like, oh, every time we try to do this wildcard query, I think it's a problem with the Datadog MCP server. Can't do wildcard queries very well. And you're like, actually, we have a set of tests tagged with wildcard, so we can show that it's not our wildcard functionality.
Yeah,
and
so
that helps them understand their side. Yeah, that's great.
Yeah, that gets into the collaboration between the MCP server team and agent development teams. Another great thing about having evals that are fast to run is that it makes devs want to write evals, right? The devs like writing evals, which is not usually the case. Like nobody generally likes to write evals. They're at least tolerable, right? And so the reason is one of the things that we can see is that what you want our MCP servers to be able to do is that you just plug it into an agent harness, and it should be able to do something cool. And perhaps right now, the MCP server with the agent harness can't do that yet, but you can write an eval first to see, okay, let's see if it can do that, right? And right now it fails. So you have a failing eval that is trying to do, but it's failing, not because something is wrong, but it's because you're trying to do something really ambitious. Then someone else could see, okay, could I make this eval pass? And say, okay, then perhaps they will try it, like they have a way to maybe perhaps refactor some of their tools. Perhaps they try a new query syntax. There are a bunch of ways to make MCP servers better. But overall, having an evals that are failing gives you some motivation to improve the MCP server so you can see those evals passing.
Okay. You can use evals to show impact. You could show, I wrote these failing ones, I did some work, and now I have some passing ones.
Yes.
Cool.
Yeah. And those traces make it nice because you have the trace that can show before the agent was doing this weird thing that kind of didn't get the answer. And after you have a passing trace that shows this agent nailing the answer. It's very satisfying to see an agent working the way it should. And then on something that you didn't think it should be able to do. It's very satisfying. Yeah.
That's awesome.
Yeah. And then the other motivation that we see people like writing evals is that, as you might be developing something, there is some subtle thing that you added to your MCP server, and you want to make sure that no one else messes with it, right? You work really hard to get this thing working, right? There was this thing, some customers was complaining that this thing wasn't working. You work really hard to make it work now, and you want to make sure that it doesn't break again, right?
Yeah, that makes a lot of sense. It's like protecting what's yours. Yeah.
Having evals that are easy to write, that are fast to run, and that are good enough that people feel that they are reliable enough as a gauge of the overall quality of your MCP server, just motivates people to run these evals and to continuously improve them.
We've gone over evaluating the Datadog MCP server, so kind of like why, but also how it works exactly. And it seems like your team has you solved a unique problem, or you said a controversial problem of automating evals, which makes it so that you can create a large volume of them and that they're easier to maintain. You can rerun to update the answers. And because of that, you have a whole host of benefits, because now we have evals that are easy to make, they're high quality, there's a lot of them, so you have good coverage, and then they're fast to run. And so you have a lot that you can do with this, a lot of the extra visibility. You have a lot of benefit that goes into not just the NCP team, but the other teams that use the Datadog MCP server internally. Everything's fast, and then it's even a little bit fun.
Yes.
Yeah. Thank you so much, Scott. It's been lots of fun. Goodbye.
Thank you. Goodbye.